Okay, in this video we will be solving various types of equations. And you'll see the equation, you have to identify the structure of the equation, what it's got for variables, and so forth. So in this first problem here we see 4x to the second power minus 8x equals 0. So, first thing you want to do is identify, since we have to solve for x, we want to identify what x has for variables. So, we have x to the second, and we have x. So when I have those things in the problem, we have to use factoring properties. You're not going to be able to combine them. Okay, so factoring properties, you're going to fill out how many answers you have. Okay, so since we have x to the second, there's going to be 2 answers. Then we make sure we're equal to 0 in the equation. We are. Then we count the number of terms that we have. We have 1, 2. So there's 2 terms. It's called a binomial. So we factor a binomial using GCF and then difference of perfect squares. So I set up those 2 boxes. They're like graphic organizers. Okay, so the GCF, I asked myself, do we have x on the end of the term? Yes, I do. They both have x, but we take the x from the end. Then I say, do we have a negative in front? Nope. Then the greatest common factor out of 4 and 8 is 4. Okay, so then I go divide by 4x. So 4 divided by 4 is 1. X to the second divided by x, that's like taking x times x, dividing it by x. We always get a remainder of x there. Then negative 8 divided by 4 is negative 2. And then x divided by x is just a dead cancellation. Okay, so I take my GCF 4x. I mean, it has x in it, so that's a factor I have. And then kind of cross that out, and I see if what I have remaining is a difference of perfect squares. Well, you have a positive and a negative. That's positive, that's negative, so that's the difference, okay? Positive, negative. It's supposed to be that way. Now, are these perfect squares, though? Well, first off, I'll circle that. And then 1's a perfect square. Yeah, that's 1 times 1, but x without a second power is not a perfect square. So this is not a difference of perfect squares. You put no. Okay? So 1 times 1, yeah, but then I run into trouble when the x isn't to the second power. So I bring that 1x minus 2 straight over here. And that's the 2 factors. Okay, so f1, f2. Okay, so 4 times x could equal 0. 1x minus 2 could equal 0. So I divide by 4, and 0 divided by 4 is 0. And over here, you don't need the multiplication by 1. You just add 2, and you got your answer. You don't need to divide by 1. That's wasting time. So that's 2. 0 and 2. Okay, number 2, 5x plus 2 equals 3x minus 6. Now, let's look through here. Structure of the equation. We have x. Then a repeat of x. So repeat means we have x only. So we don't use factoring properties with the only. We use linear properties. Okay. So in linear properties, that's on the other side of the sheet. That's when we got only one type of x. You fill out how many answers there are. This one would only have 1. Okay. You collect the x terms if you have more than 1. We have more than 1 on opposite sides, so we take out one of them with addition or subtraction. So let's take out the 3x by subtraction. So it gives me 2x plus 2 equals negative 6. Because that is a negative 6. Then you solve, okay? So got 2 times x plus 2, so we minus 2. Negative 6 minus 2 is negative 8. Divide by 2, divide by 2, and that's negative 4. Okay, so negative 4, and we don't do a square root because it's not to the second power. Okay, number 3, we have x to the second power minus 9x plus 20 equals 30x minus 4x. Okay, so structure of the equation for the variable, you have x second, then you have x, then you have x again, so that's repeat. Okay, so just x second and x, but you still have to use factoring properties. So we're back to factoring properties, 2 answers. But now you got to get equal to 0 here. You are not equal to 0. So you have to take out those 2 terms one at a time. So you subtract 36, and 36 is a constant. So this is x second, x, 20 is a constant, so I could subtract 36 from 20. Then I got this negative 4x, I'll have to add him. And then that could go with the, remember that's x, I find something else with x, not x to the second. X would be your negative 10, so I'd add 4x to that. Okay. Now we got our 0, now we have to collect the like terms. So we have x to the second, x, and a constant. Okay, so x to the second we have 1. Then x, negative 10 plus 4 is going to be negative 6. And then 20 minus 36 is negative 16. Okay, so now you're equal there. Remember, that's negative 10 plus 4, not 10 plus 4. Okay, so now I see my 3 terms. So we do GCF table. Okay, so I think you got no x, no negative, and then 1, 6, and 16 would just be in row 1. Okay, so 1 is your greatest common factor. Okay, so I take 1 times negative 16. That's going to be negative 16. So that's a mismatch, because we have to find 2 numbers that multiply to negative 16. And those numbers also have to add to negative 6. Okay. So 116. Well, that adds to negative 15. 16 divided by 2 is 8. And I think that's your negative 6. Okay. So put it in your parentheses. So you get your positive 2, you get your negative 8, and your a is 1x to the second power. Okay. And then 1 can be just 1 times 1. Okay, so 1 and 2, you'd really only be able to divide those by 1, and then 1 and 8, 1, so that would just stay the same. Okay, so you got your 2, and cross out that top row. Okay, these are the 2 you're at. So we have a factor of 1x plus 8, and we got a factor of 1x minus 8, and then equals 0. So F1, F2. Okay, so when you have multiplication by 1, you can just get rid of it, and you'll subtract 2. 0 minus 2 is negative 2. Multiplication by 1, get rid of it, you plus 8, 0 plus 8 is equal to 8. Okay, number 4, x to the third power plus 2x to the second power minus 9x minus 18 equals 0. This looks like trouble. We have an x third, an x second, and an x. Well, that's definitely factoring properties. Okay. So x to the power of 3, that means there's 3 answers. Okay. You got 0. But unfortunately, we have uno, dos, tres, cuatro, 1, 2, 3, 4 terms. So we have to do the grouping procedure. So this is called grouping. So parentheses plus parentheses. Then line parentheses plus line parentheses. Then little parentheses, big parentheses. And that big parentheses, of course, we want to check and see if that's a difference of perfect squares at the end. It's possible. Okay, so we group the 1x to the third power plus the 2x to the second power. Then we group the negative 9x with the negative 18. Okay, so remember, these little lines out here are GCFs, but not thought through the whole thing. You're just looking 2 of them at a time. So I have x to the second on this last term. Okay, so we have x on both of them. X is common to both, but we take the one on the end, the x to the second. If you just take x, it's screwed up. Then there's no negative in front, then 1 and 2 is 1. Okay. Okay, there's no x on the end here. There's a negative in front. Then 9 and 18 are both 9. So then we'll go up and divide by 1x to the second right here. And we'll divide by negative 9 here. So 1 divided by 1 is 1. Now the x third divided by the x to the second, get a remainder of x, and then 2 divided by 1 is 2. Then x second divided by x to the second is a dead cancellation. Okay, then that's going to be also 1x, and negative 18 divided by negative 9 is positive 2. Okay, so 1x plus 2, 1x plus 2, we're going to factor that out into the tinier parentheses. And then now we're left with 1x to the second minus 9, okay, negative 9. You don't put plus net. Well, you can put plus negative if you want. Now, first off, one thing I'm going to clue you in on, at this stage in the game, if you end up with these 1s in front of the x's, you know you're not going to need them because that's 1 times x, and I always don't, we don't need those, so I'll just bring over the x plus 2. And then DOPS, difference of perfect squares. So the difference, well, we got a positive and a negative, that's right, okay. Are these perfect squares now? Well, x to the second is, because we can write that as x times itself. 9 is, because we can write that as 3 times itself, okay. So, x, 3, 3. So we cross this out. Don't bring that over because now this has transformed into x plus 3 times x minus 3. Equals 0. Now we're going to get our 3 answers, F1, F2, F3. Okay. Minus 2, I get negative 2. Minus 3, I get negative 3. Plus 3, we get positive 3. Okay, those are your 3 solutions. Okay, number 5, we have 14x to the second minus 3 equals 2x to the second minus 16x. So when I look through that equation, I've got x to the second, another x second, I don't need to repeat it, and then x. Okay, so with those two things, that's factoring properties. So there's 2 answers, okay? Okay, how many answers equals 0? No, we need to get this equal to 0. So I have 2 things I need to take out. First, I take out, and you're adding and subtracting, not dividing. So you subtract 2x to the second, and I have an x to the second to go from there, the 14. I'm going to have to talk about that when we go to do it. Then, that's negative 16x, so we need to add 16x, and there's no x to add to. Remember, x second and x are totally different terms. So we put that right there. Now, you start with x second. When you subtract these, the second powers do not go away, okay? The powers only change on multiplication and division. When I add and subtract, the second power is going to remain the second power. So x second, x, constant. So 14 minus 2 is 12. And then you can't put you got to put your x, the 16. It's got to be in standard order. And then negative 3. Okay. Now, there's my 3 terms. So we know there's 3, so it's going to be GCF table. So x on the end, I think not. Negative in front, I think not. 12, 16, and 3. It's either 3 or it's going to be 1. 3 and 12, but 16's not. So the greatest common factor they all have in common is 1. Okay, so I take 12 times negative 3. And that's going to be negative 36. So that's obviously a mismatch. A positive times a negative, and that's got to add to the b term, which is positive 16. So 36 divided by 1 is 36. I add those, that's negative 35. That's way too wide. Okay. 36 divided by 2 is 18. I add those, that's negative 16. Okay, so we found the factor pair. Okay, we just need to make it into positive 16 because right now they add to negative 16. Well, then I'm going to make the 18 positive and the 2 negative. Okay, see, if I take negative 2, can't see that, light's in the way. If I take that negative 2 and add 18, there I'm at 16. Okay, see if I would have just left it, the 2 and the negative 18, that adds to negative 16, and we need positive 16. So it's these two. And also don't stop dividing until you're too narrow. Okay, see, or too small to get to what you're trying to find. Okay, now a is 12x to the second. Don't you remember that? Put in your negative 2, put in your positive 18. Now we got x to the second. And then 12, you put in front of each one. Now you need to reduce these, okay? Simplify them. So 12 and 2, here's 2, here's 12, they're in row 2. 12 and 18, so 12, nope. 12, 18, those are in row 6. So it's going to give us 6x minus 1. Cross that out, and the 2 we're dividing by, we don't do anything with. And this gives us 2x plus 3. Now, remember, in the end, before I come over here, I got to make sure the values I have multiplied by x, 6 and 2, they got to be exactly what's in front of x to the second. We'll take 6 times 2, that's 12. Boom. Negative 1 times 3 is negative 3. Booyah. Okay, so you bring over 6x minus 1 times 2x plus 3 equals 0. Okay, so F1, F2. 6x minus 1 equals 0, 2x plus 3 equals 0. So we got multiplication by 6, we have to add the 1, that's 1. Okay, 1 divided by 6. You can put 0.17 or 16 repeating, or you can just put second PRB that back to 1 over 6. So you put the decimal or 16, I don't care which one. Okay, now right here you got multiplication by 2 and plus 3, so subtract 3 from both sides. 2 times x equals negative 3. Negative 3 divided by 2 is negative 1.5. Okay. Okay. Number 6, 4x to the second power minus 6 equals 90. Now, you have x to the second only. Okay? Only. So there's two answers, okay? But you're not factoring, you're using the linear properties with the only. So fill out how many answers there are. We've already done that. Collect the x terms if you have more than one of them. I don't have more than one of them. I just have this one. Okay? Now you solve. Solve means this. Okay? So mark your multiplication. You got the second power. You got -6. Those are the three operations. So there's three things we have to do. First, plus 6. 96. Then divide by 4. That's the second thing you do. 96 divided by 4 is going to be, I think it's 24. It is 24. Now, what number times itself is 24? That's a good question. You take that out, second square root the other side. It's positive, negative. So I find the square root of the value 24. 4.8, just put 4.90, please, or 4.9. So 4.90 or negative 4.90. Okay, next problem. 4x to the second power minus 36 equals 0. Again, look through that problem. You have x to the second only. Okay, so that is linear properties. It is not factoring. We do not want to try to factor this. You're wasting time. Okay. So fill out how many answers there are. We've already done that. There still has to be two answers. Collect the x terms if you have more than one. We don't have more than one. Now solve. So mark your operations. You got times 4, a second power, a minus 36. So first we're going to plus 36. Then we're going to divide by the 4. Then with that second power we square root. I've spelled out the three things we need to do. Plus 36, so that's 36. Divide by your 4. That's 9. Then square root. Could be positive or negative anytime you do a square root. And guys, 9's a perfect square. It's 3 times 3. So it's going to be 3. So 3, negative 3. Okay, number 9, we have 5x to the second power plus 3x equals 7x to the second power plus 7x. Look at what's going on with x for the variable I have to solve for. You have x second, and you have x, and then you have repeated x second and x. So it's x second and x. Don't write repeats, okay? So same variable, different power. That's factoring properties. So once again, I'll be filling out how many answers I have. There would be 2 equals 0. We do not have our 0. Okay. So we need to take these out one at a time. So I subtract 7x second. And you can get rid of this. You can get this side at 0 too. There's no rule that says that's the side that has to be 0. But I'll do it. Minus 7x, now that's an x, so we'll subtract that from 3x. Okay, so you're going to have the 0 over here. There's nothing left over there. So we have x to the second, and no, once again, on adding and subtracting, those do not change powers. Okay, they don't cancel, they don't do any of that. The powers only change on multiplication and division, and that's not what we're doing here. We're subtracting. And then we have an x, and then I don't need a constant space because you don't have any constants. It's just x to the seconds and x. So 5 minus 7 is negative 2, and then 3 minus 7 is negative 4. So now you have two terms. It's a binomial. So all you have to do is the GCF. Because again, over there's two terms. There was no constant. And then we'll check and see if we have a difference of perfect squares. Okay, x on the end, yep. Negative in front, yep. 2 and 4. It's 2. So yeah, negative, you got to factor out negative 2x. Okay, negative 2 divided by negative 2 is 1. Then we divide the x second by the x. We have x. Negative 2 divided by 4 divided by negative 2 is positive 2. Then we divide the x by the x, and that's a dead wipeout. Okay. Now you got to bring your negative 2x factor over there. That's important. And then dops, no. They're both positives. It can't be dops if difference of perfect squares if they're both positive. So you wipe that out and just put the 1x plus 2 next to it. Okay, so F1, F2. So negative 2x could equal 0, or 1x plus 2 could equal 0. So you divide by negative 2 here, and you get 0. And then get rid of your times 1 and minus 2 from both sides, and that's negative 2. Okay, that's it.